Hello everyone, welcome to my YouTube channel A to Z Automation. In today's video, I'm going to demonstrate to you how you can exchange data between two Mitsubishi PLCs using simple PLC communication over an Ethernet protocol. So let us begin. First of all, we will create two programs with two different names. I'm creating new project here. We will save it. I'll name it PLC1 underscore 25. One more project we are going to create. Let's minimize it. Second project is getting created now. Now we will save it as PLC2 underscore 35. PLC1 and 2, these two are the programs. 25 and 35 are the IP address extensions that we are going to use. Before we start writing program, let me show you how we are going to use addresses. This is the address mapping that I have created. This is our first PLC having an IP address 192.168.1.25, and this is our second PLC having an IP address of 192.168.1.35. Uh, so basically we will exchange data between both the PLCs. So this is an address mapping. I'll elaborate this to you as we proceed. So first of all, let us begin with writing a program. This is our first PLC, PLC1 underscore 35. So before writing program, we will do one thing. We'll go to parameter and do parameter settings. Where here, this is the path parameter FX5U CPU parameters, module parameters in that Ethernet port. Yeah. So in these basic settings, we will set IP address 192.168.1.25. We'll add subnet mask also and gateway as well. Now apply, check. No error. So the same thing we'll do in second PLC. 192.168.1.35. So here also we have added basic settings. No error. Now the second step is little important. After having done these basic settings, go to this application settings, and in this we can see these are the options available. So as of now, our focus is going to be on this simple CPU communication setting. So double click on that, and here you can see simple CPU communication setting. Here it is mentioned that not to use. We'll click on that, click on this drop down menu and put this into use. Okay. So now expand this detailed settings, double click on that. Now this is an area where we are going to uh, write these address mapping so that we can exchange data between two PLCs. Okay. Now this read, write. Also one important thing is that here the communication setting execution intervals can be changed as per user requirements. Both the two options are available here, fixed interval and on request. For this video, we are going to use fixed interval. Now here you can see as the IP address of this PLC is 1.25. So this is our host station. So here we have to select the another PLC address. Click on this uh, device type. We have to select. Click on this. Our PLC is of Melsec IQF built-in Ethernet. This is the option we are going to select because the selected PLC is of this model for both the programs. So we'll write here IP address of second PLC, that is 192.168.1.35. And this UDP communication, these settings are going to remain as it is. Okay. The same changes we have to do here in destination communication destination of right row. Let's say IQF 192.168.1.35. Okay. Now this thing is done. We have to set addresses. Type of addresses are important. We are selecting as memory bits. This M80 to M159. The 80 points. These 80 addresses are going to be used. 0 to 79. First, let me add these addresses and then I'll elaborate to you what is the meaning of each address. I mean, for what they are going to be used. Now, here the data registers we are going to use. D0 to D63, 64 points, and D128 to D164, D128 to D164. D64 to 127, and D166 to 202. Now let me tell you the meaning of this address mapping. This is our PLC1 having an IP address 25. So which is also host for this communication. Now this data from these addresses M80 to 159, this data from this address range is going to be read in this first PLC, and data from this address M160 to 239 is going to be written in the second PLC, that is with an IP address 192.168.1.35. Now we will go to second program and do the same setting, and this thing will be more clear to you as we write program and do testing of it in simulation mode to see how the data is getting exchanged between two PLCs. So yeah, let us go to second program and do the same setting. So I'm going to put it in use mode, simple PLC communication. Click on detailed setting. Again, do read, write. These two rows are added. Communication setting is fixed interval. And here for this program, our IP address is 1.35, which is also our host station. And here the source is going to be the first PLC. Again, select here MailSec IQF 192.168.1.25. Same setting we'll do here in destination of writing. Uh, the video might get little longer, up to 30 minutes, because I'm deliberately making it slower to make it more clear to the new beginners. Now, the same address mapping will be done here. M80 to M159, M80 to M159, first 80 points. M0 to M79, M160 to 239, M240 to 319. Now data register range we will enter D0 to D63, 128 to 164, D64 to 127, and lastly D166 to 202. Now we will do setting. Check, no error found. So this will be done for both the programs. Apply settings, check them. Now we'll rebuild the program. The program is getting compiled now. Same will be done for both the programs. Okay. Now let me show you what we are going to do quickly. So the data from PLC2 is going to be written to these addresses in PLC1. That is, whenever a bit from M80 to 159 is going to be high or low, same will be reflected in PLC1 over these addresses. And the same is true for this address mapping. That is, whenever a bit will be changed to high or low in PLC1, that is going to be reflected in these addresses. So let us see it uh, in uh, in a simulation mode. So let me open POUs, program POUs, that is program body for both the programs. Yeah, here we are. And for forcing on and off addresses, we will consider addresses that are not included in these range of addresses. So we'll take M700 and we will force on M80. So as per this mapping, whenever M80 is uh, high, that is it is 1, 160 should turn on. So we have written a simple program here. Whenever a bit uh, M80 will be high in program 2, PLC2, it will turn this M60 address high, and the result will be this register uh, will have a value 25. So first of all, let us compile both the programs. Okay, both the programs are compiled now. And here one more thing is that we have to put both the programs in simulation mode using this option debug. Go to simulation and don't start, in simulation, and don't start the simulation. It will work for only one program. Go to the system simulation and start simulation. Okay, now we have to add both the programs to this GX Simulator 3. Add system. The first program, you can see I'm adding it. Now the second program we are also going to add. Click on this add button, browse it. This is our second program. Add it. Okay. Now you have to start the simulation. Yeah, we have started simulation. Both the PLCs are powered on, of course, in simulation mode. They are not in run mode. So error is getting flashed on both the PLCs. So we'll write both the programs. We'll download the programs. So for that also go to this option in simulation mode, in system simulation, and click on this connect simulation. After doing that, go to this option online and click on this write to PLC. This window is opened. Select on, execute, close, close. Now this window is in monitoring mode. The same will be done for second program. Go to this online option. First go to debug, then simulation, then system simulation. Click on connect simulation, connect, and go to this online tab. Go to this write to PLC, select all, execute. Close, close. Now you can see in simulator the error has gone now. Both the PLCs are in run mode and powered on. Here also you can see that thing. This is an option to put window in run mode. Now, as I stated earlier, as per this address mapping, whenever MAT in PLC2 is high, it will make M160 in PLC1 high. So let me show you how you can monitor that. First of all, we will force on this bit using Shift Enter shortcut. This MAT I have forced on. So now you can see in program 1 M160 is high and the instruction is executed. It's been already 21 minutes. Let me show you one more instruction and we'll stop this video then. Suppose you have to just reset this address, this register using the second uh, command from second PLC. So how you can do that? Let me show you. We'll put it in write mode. This write mode. We'll add one more address here. Uh, yeah. Instead of doing that, we'll do one thing. We'll go to first address and okay, yeah. We'll write one simple rung here. On falling pulse of this address M160, we'll reset. We'll move 0 to this address M160 falling pulse. Use move instruction move K0 to D500. Now what you can do, we can write program online program change from this option. Click on yes. The same thing will be done for second program. Yes. What will happen? Let us put both the programs in monitoring mode. As you can see, this 160 is high because this MAT is high. We'll do one thing. We'll force it off. MAT has gone to 0 from 1 and 160 has also gone to 0 state. So on falling pulse of 160, 0 is moved here. Again, if you force it on, M60 will go true and 25 will be moved to 500. Okay, that's it for today and hope you like my video. If you like my video, please subscribe my channel. Please subscribe to my channel and share it to your friends. For any improvements and any suggestions, you can write in comment section. I'm going to write my email address in comment section. All the instructions, suggestions are most welcomed. So we will stop this video here. Again, I'm going to add a few more videos on this topic. in coming days. Uh, Thank you so much.